Hello, welcome to IBM TechCon. We're on day 3, second session, so we're going to keep moving along. Most of you are already used to the procedures, but just in case you're new, make sure that you are asking questions in the chat. We want to hear from you. Our speakers are here to answer your questions, but we are going to keep moving. And the next topic we are very excited at IBM to welcome HashiCorp to the IBM family. And we're going to focus in on infrastructure lifecycle management. So really exciting new capabilities. And we have a developer advocate, Cole Morrison from HashiCorp, as well as Director of Product Marketing, Kyle Ruddy. And they're going to take you through some of the solution. So make sure you're asking questions. And with that, I will hand it off to Kyle.
Excellent. Thank you so much for the introduction there, Peggy. As she mentioned, we are very excited to walk you through the next hour or so as we talk a little bit about infrastructure lifecycle management, what that means, and really the end goal here being to maximize those investments that you have going into your cloud initiatives, regardless of that's, public cloud, private cloud, hybrid cloud, and really how HashiCorp can be there every step along the way of the process to help you get to those end goals of success. However, I think we're going to start off with a nice little demo to kind of show you, kind of the end result. Like, what does good actually look like, so that we can then go back and take a look at how we got to that point. So let me hand it off to Cole.
Yeah, thanks, Kyle. So let's take a look at a scenario where we have, say, an application that is, an end user facing application that may reach out to a number of other public or private services. And then those public services or private services may be reaching out to other private services, with the catch of these services all being across different cloud environments, being run by different teams, perhaps teams of teams, while all still needing the connectivity and the workflows between each other. Now, if you're thinking about this in terms of managing this, that's obviously a part of this talk, but just the idea of adding a new one, that's quite a bit. However, we're going to show you this end result where we're going to get this done as a developer very quickly without having to bother anyone on the platform team to get this done. So I'm over here in HCP, our HashiCorp Cloud Platform. We're going to head into Waypoint as a developer. And inside of here, we're going to go and create a new application, choosing from one of the different templates that our platform engineers have made available to us. We're going to deploy a new application inside of our game Kubernetes cluster environment. So inside of here, we'll see that the platform team's given us the ability to change 2 different configuration settings. We'll just call this one ELO for rating for the different players of the game. So I'll just type in ELO, click Create Application. Now, it looks like I've already created one named ELO, so let's call it Scores. Look at that. It won't even let the perfect on the fly error there showing that I can't make a mistake. We've really thought that through, haven't we, Kyle?
Absolutely.
Yeah. So I'll click Create Application here, and that is all that I needed to do. This is then off into the races. And, as a developer, I'm ready to go here. But as a platform engineer, I get a view into every single thing that's actually going on. If I click this application workspace, we can see the entire run happening in HCP Terraform here. We have the plan saying exactly all the things that are going to be created. In addition to some policies we have, which we'll be able to talk about later in terms of setting up guardrails to make sure that we don't do anything that we shouldn't be doing. And then here we have a queue applied up that's going to go and actually make the thing happen. So while we sit here and wait for this to finish, Kyle, do you have any quick thoughts?
Yeah, so one of the things I want to call out here is a little bit of the context switching that Cole was mentioning. What we saw initially was, kind of that internal developer portal, being able to self-service access to these resources and to the end result here being an application, followed by having that conversion of being able to switch over, putting on the different, persona hat, if you will, of having that platform engineering perspective and seeing what's going on behind the scenes. Now that is one of those cases on, where maybe permissions or RBAC would be introduced to create that separation of duties, because maybe our developer doesn't need to have access to this level of information. However, it's there, it's provided in case it does help.
Mm-hmm. And as we dig through here, there's even more details in terms of, exactly what's changing across these different resources. And then, of course, here at the end, seeing exactly what's been created. Now, this is obviously going to take maybe, a handful of seconds to actually get thrown into our cluster itself, but we do have console going in the background as a service mesh that actually has a view of all of our services, and we will see that this scorer service has just freshly joined the rest of our service mesh and is now ready to communicate with all of the other services if we would like to allow it. I think that's the end of our quick demo, Kyle. So back to the slides.
Yeah.
Right.
Gotta love live demos. All right, so with that, Peggy already introduced us, but just to high level it, my name is Kyle Ruddy. I lead up the product marketing group that is focused on all things infrastructure lifecycle management.
And my name is Cole Morrison. I'm a senior developer advocate, and I get to experiment, demo, and learn about, talk about, and show off the variety of our different tools.
All right, so let's dive into some of the content here, and let's talk about the why. Let's talk about the why. Like, why does that matter? How does that help organizations, and how does that kind of bring about the end result being enhancements to the business itself? So a lot of organizations are going through this transformation as they're bringing on various levels of different cloud initiatives. A lot of these cloud initiatives kind of bring on infrastructure challenges and really take a look at how fast companies can get to a certain point. And what happens when they get to that point? How are they facing new challenges that are kind of emerging out of those new challenges and new capabilities really that they're realizing as part of these initiatives? And in many cases, there's a lot of fragmented tools and lack of automation that kind of rear their ugly heads in terms of this. And some of our analyst friends have pulled out metrics saying that 62% of companies are seeing kind of a lost time to market value in terms of how do they get from point of request to the point that people can actually consume those services. And at the same time, there's 75% of organizations that are finding security breaches that are being found as a result of misconfigurations. And what that really kind of leads to is just kind of a lack of trust, and those compliance regulations or reports can they can be a little more difficult to process and work through. And then, of course, as these initiatives are going on, there's, of course, a cost that's associated with that. So any level of inefficiencies should really be rooted out as soon as possible, because, certain folks are seeing, 32% of cloud spend is wasted annually. And really part of that is, how do we make sure that we're making the best use of our resources that what we have? So if we jump to the next slide. The end goal here is, and this is kind of what the demo that Cole was showing us, was to unblock our developers and our own internal customers within these organizations to really drive innovation. However, as we're driving innovation, we still want to make sure that we're staying secure and we're staying compliant, and we're still making sure that we're making the most efficient use of not only our budget, but those resources that are available to us. If we take a look at the way that things have been done, there are bottlenecks that come down to, traditional ticketing methods. If you have a developer who needs to submit a ticket in order to gain access to those resources, what does that timeline look like in your organization today? And even if you do kind of hand off, some of those capabilities to that end customer, what kind of controls and what kind of policies are placed around that type of workflow to make sure that security guidances are followed and organizational best practices are integrated into the way that operates. We don't want to see security become kind of an afterthought, or in certain cases, resources being deployed and then never cleaned up and just left running out there in the environment. And really, we see a lot of these challenges that are happening quite a lot. And that's kind of where the whole premise of infrastructure lifecycle management comes from. So if we want to jump to the next slide here, this is really where HashiCorp comes into play. Now, of course, we're one of IBM's latest acquisitions here, so we've got our updated graphics. And what we have on the HashiCorp side is the infrastructure cloud. And what that does is it focuses in on two main areas. Now, the one that we're focusing on in this session is going to be on the left-hand side. That's the infrastructure lifecycle management. But there is also another side of this, another component that goes into security lifecycle management that is very present within all of the demos that we're going to walk through. However, we're not going to be focused on it. There is actually another session that covers that and really walks through, how are, like in our demos, how are we managing secrets? How do we, authenticate to that Kubernetes cluster as part of Cole's demo? How do we make sure that, there's policies to kind of govern who has access to what in terms of those secrets, either credentials or public keys or, even private keys for that matter? And how do we ensure that, Cole, with his developer persona hat on, how does he only have access to the very specific things that he needs in order to get his job done without giving him access to much more than is actually needed? And how do we do this in an automated fashion, like console popping up the score service there in an automated fashion that allows us to make dynamic changes based on that view? Now, with that said, we're going to dive into the infrastructure lifecycle management side, and that's really where we get into the whole, actually, if you want to go back a slide there, that's where we get into the kind of the simplification of how we manage infrastructure. Because not only are we managing infrastructure, but we're probably going to be doing it at scale. And so how do we make the most efficient use of that infrastructure? How do we codify that? How do we also bring that same level of codification into the way that we also build and create and manage our images within our environment, regardless of whether that be virtual machine images, container images, and so forth? And how do we do this in a streamlined approach so that the folks who need access to their resources, to their images, or just to their application can do so in a consistent fashion, and they can do that across any different initiative that you are supporting as part of your cloud projects? So now if we jump into the next slide, let's talk about the actual products that support the underlying use case behind the infrastructure lifecycle management portfolio. Now, the end goal behind all of these products is really to help build, deploy, and manage the lifecycle of our infrastructure and applications. And we have four main products that do that and are focused in on that. So first we have Terraform. Now, most people have probably heard about Terraform if they're doing anything in the infrastructure or even infrastructure as code space. It is all focused in on being able to declaratively define infrastructure and build it from that point. Then we also have Packer. That's another one that's been around for a while and is fairly well known. That's focused in on maintaining those images as code. Then one of the newcomers that Cole showed off as part of the demo is Waypoint. That's our automated developer services platform that was allowed Cole to go through and self-service that application. And then we had Nomad, which we'll touch a little bit on later, but that's all focused in on being able to schedule and orchestrate various workloads on whatever service that you happen to be consuming. If we want to jump into the next slide and kind of, getting into the root of it here, there's a lot of different options when it comes down to the concept of infrastructure lifecycle management. So why is HashiCorp generally going to be your best option? And first and foremost, it comes down to the commercial offerings, because those are enterprise ready from day one. This allows you to move your focus from, being able to support those underlying workflows into building and providing value to the business. And it's also why our enterprise support is there to help. We also have a lot of years that are built into maintaining and creating these different products and offerings. So to help, we've seen a lot of different complex workflows, and so we've gone through the workflows of simplifying a lot of how those resources are built and how they are managed throughout the entire life cycle. And we were able to do this at scale. You can programmatically assign all of these configurations to help you, no matter if you're single site, single region, or multi-site, multi-region, multi-cloud. And so as part of kind of the way that we've grown as a company and kind of built out this process, there's a blueprint for how this all operates and what we've found for driving success. So Cole, if you want to jump to there we go. And so the three key stages that we found to really finding success and kind of applying a blueprint, if you will, to driving adoption and finding success in these cloud initiatives is really around how do we approach the first stage here, which is adopting. Adopting is generally that very team-focused ad hoc usage of various tools. You'll find one team who has found one set of tools and does certain things in one set of ways. Another team might be doing something else. And while that's important to kind of get you up and running, that also then leads us into that next stage of stage 2 being standardizing. And that's kind of where many organizations start finding, the concept of, say, a platform team that kind of takes all of the efforts that those individual teams have created and built as part of stage 1 and literally builds it out into standards that can be applied across different groups and even the organization as a whole. And there are various steps that kind of go along with supporting that standardizing stage, which ultimately gets us into our third stage of scaling, which is really all about how do we get back to that self-service workflow. However, doing that also while still being compliant, still making the best usage of all those resources that are available to our organization. So with that, let's jump into our next slide, because we're going to start off by taking a look at our stage 1, which is adopting, which is generally around first composing infrastructure, then collaborating on it. However, instead of continuing through on the slide view, we're actually going to jump over into a demo and have Cole lead us through.
Sounds good. Well, we've already seen some of the stuff, specifically the end result, the end goal that we're trying to lead to. So this set of public end user facing services, those specifically being this game, social, store, and then one in the background we don't see here, which is a reports service backed by a variety of private services, all in different cloud accounts. So that's great and all, but how do we get to that? Right, if we're in the adopting phase and we're looking at infrastructure as code, we have to question how we're doing things currently, which might be ClickOps, right? We may be going through the user interface, setting up individual firewall rules or security group rules or whatever they're called for the cloud provider that you're using. But if we're using infrastructure as code, well, let's take a look at the second asset here that we have available to you, and that's this Git repo. And this is all of the infrastructure as code powering the full demo that you're going to see Kyle and I walk through today. This has every detail in it, so if you are a developer or want to hand this off to your developers, they can dig through this and see everything required to get up and running. So just know all those details are here if you're interested in the actual implementation. Now there's 6 directories here to take note of. Let's go over 5 of them: the game, global, report, social, and store. Each of those represent a different cloud environment, entirely different, say, in this case, AWS accounts being backed by either team or team of teams. And if we're looking at the infrastructure as code aspect, the workflow we'd probably want to take, let's hop into this game project. And the way to think about it, sure, this is a directory, but if we're thinking infrastructure as code, this is now the game environment, the game cloud environment. And within it, we have a variety of subdirectories. We're going to kind of think of these as workspaces. They're the different components of that environment. And specifically, let's take a look at the infrastructure one. So this is all the infrastructure that's hosting all of the services in the game environment. And let's go into this HCP file. Inside of it here, oh, look at this. We'll see some security group rules, very declaratively laid out, showing the different ports. And Kyle, what are your thoughts on this file?
Yeah, so even though this might seem a little daunting at first, seeing various different directories and whatnot, the key part about this stage is really taking a look at the ability to read through this code. It's very simple, it's very straightforward to kind of see and kind of grasp what is happening and what each of these resources are doing and what their intentions are within their given service.
Yeah, now what's interesting about this is yes, this is very declarative, but there is a lot of it. And if we're looking at making multiple workspaces, right, in context of multiple cloud environments that are being used by multiple teams, well, repeating ourselves here can be both inefficient, but also in some ways insecure. So let's take a very big example. Let's say that Kyle has now tasked us with creating an entire new cloud environment with an entire new runtime requirement, whether that be Kubernetes Nomad, or maybe just raw virtual machines. Well, in the case of that, that's a lot of extra code to do, and it's a lot of room for error, but we can use something called modules. And let's actually see how this game environments use that. And we'll see here within about 8 lines, they've got their entire Kubernetes runtime up and ready to go, Kyle. So what do you think of that?
Yeah, this really helps in not only just the repeatability, but when it comes to how organizations standardize on how they deploy various resources, this is where you can start building those in so that you limit yourself from what we just saw with over 80 lines of code, and it's reduced down to literally just about 8 lines.
Mm-hmm. And you might be wondering, well, where does this code look? What does this look like? Well, that was that 6 folder I just sort of brushed past, and this was this modules folder. Modules are going to remain very important throughout the rest of the demo and presentation. And we can see here that it's referencing a module in the infrastructure module, specifically the EKS one. And inside of here, we can see the full implementation of this entire runtime. So there is stuff that we did have to invest here to get this set up and done right. However, once done, it's something that can be reused time and time again. So do you have any thoughts on this before we move over to HCP Terraform, Kyle?
Nope, let's move on to HCP Terraform.
All right. Well, so the question is, wonderful, you have all the code, but how do you actually get this deployed? What actually runs this? Well, of course, you could use the local binary, but we're trying to head towards that scaling side of things. So we're actually using HCP Terraform. And if I hop over here, we can see that much like our Git repo, since we're using a version control based workflow, we have a game project, global project report, social project, and store all being mapped to those very similar folders over here. But before we get into much more, Kyle, give us an overview of what we're looking at here.
Yeah, so this is a visual representation of how Terraform kind of operates within HCP Terraform. So as Cole was laying out how we have various projects that are kind of aligned to each of those folders and directories, that's an abstraction layer that allows us to kind of logically separate out each of those groupings of resources to allow us to manage them in maybe ways that make sense to in this case, us, but also you all to manage them more logically in the way that you operate your day-to-day.
All right, so why don't we hop into the workspace that we were looking at, so that associated folder that we'd opened up and dug through those security groups. Now we open this up, we're going to see this awesome dashboard here of a lot of different information, a lot of different things going on. It's a lot to take in. Obviously, a lot of information generally leads to knowledge, which is better decisions. And Kyle, what should we be focusing on in this view?
Yeah, so this is a visual representation of basically the output of a Terraform operation. So this is Terraform going through running and creating resources within this particular workspace. Based on the logical kind of segmentation that we've built out. We can see certain things at the very top line, like there's 93 resources that are in there. We can also see information such as the latest run or the latest operation that Terraform has had that was based off of a call within the UI that happened to go through. And in this case, there was only one resource that had to be changed or updated. Then below that, we can see a list of all 93 different resources. So we have a good understanding of what this workspace is doing and kind of operating behind the scenes, as well as a series of outputs that kind of allow us to have more contextual information and, more importantly, the ability to reach out to perhaps deployed services or applications to start interacting with those.
Yeah, so let's take a look at, let's go into a little bit more in depth of what happened in this latest run so we can see some more of what's going on here. And we'll see, well, if you used Terraform before, but perhaps not. Well, we have 3 operations here, but there's probably 2 that Kyle wants to hone in on here. That's the plan and the imply. The plan, updating this node group recently, since I was past me was smart enough to name the actual run here correctly, and this apply. So Kyle, what should everyone focus on here?
So when it comes to stage 1 and kind of that initial consumption of Terraform and infrastructure as code, there's 2 main kind of avenues that Terraform operates. And first is the plan that we see up top. That's literally Terraform consuming our configuration and saying, okay, this is what we need to reach out to a service and figure out how do we get from where we are today into our desired state as it's been documented. And so this is the plan. And so in this case, we can see that we already have those resources that have been created. But in this case, we've had a change that requires our scaling group to move from a desired size of 2 into a size of 3. And this is kind of a very nice graphical way that you can tell exactly what's happening with that given Terraform operation. Then after the plan, that's when you move on to the actual apply phase. And the apply is what actually creates or modifies resources within an environment. So very similarly, we can see that that node group had their change into their given size. And then it also provides us with any of the outputs that are required that go along with any changes that might have happened with that Terraform operation.
Yeah. And right here at the bottom, we see something called state versions created. Now, unlike other different templating languages, Terraform actually, between state and all the other things that we've talked about here, is the representation of your infrastructure as it is as code. And one of the key pieces in making sure that happens are the state files. So I'm going to click into state. And Kyle, why don't you tell our audience a little bit more about the concept of state and why this is important?
Yeah, so the state is exactly, it's an understanding of what Terraform knows about your environment. This is taking all of the resources that you have defined, and Terraform then goes through and documents it against your given service. And then it stores it here because that is how Terraform goes through and does those subsequent updates or operations to continuously build out. So it knew in our last case there that there was only one resource that needed to change, and it was really only one attribute that needed to change. And that kind of simplifies the entire process instead of having to go out and scan everything that might be in your environment. Because in certain cases, especially at scale, that can be a daunting and time-consuming process.
Yeah, so state is going to become a very, very key concept once you do get into the nuts and bolts of Terraform itself. But because it does represent that, ongoing live infrastructure, the question then becomes, well, how do I reuse this, right? How do I switch this? How, if I'm doing trunk development, do I make it so that I have different environments perhaps without replicating, duplicating code, right? Amongst other things that we need to get into, and that's going to be variables here. So I'm going to hop over to variables. And so we've got some stuff going on this page. Kyle, what should everyone focus on here?
Yeah, so we have a couple different options when it comes down to variables. In general, you can define these directly in your configuration code, and it's very easy to kind of place these on a workspace by workspace basis. We can see in this case, we have certain organization names, public subdomain names, things along those lines. However, as you kind of grow and you kind of scale and evolve out, there are also needs for these notions of variable sets that we have here below that are literally groupings of different variables that are kind of defined and grouped together for certain reasons. In this case, we're looking at 2 different variable sets that are arranged around credentials. These are things that, every time that you have a certain client ID, that's going to have a specific secret that goes along with it, typical username, password type fashion. The other thing that we want to point out here is the sensitive marker. So because these are credentials, maybe we don't want that exposed to whoever might be accessing this workspace. So that is another kind of nice feature that we can apply this across either a project or several workspaces so that there's consistency in who is authenticating, or really how Terraform is authenticating to an environment.
Now, that's really important because, if I'm heading up a platform team and they're all working on different projects and those different projects require these common credentials, this is a very easy way that I can ensure that these are accurate, correct, correctly guarded at once, apply them, without them even necessarily needing to think about it and them having exactly what they need. So speaking of teams, right, so far we've just kind of been looking at this from the view of just one person operating this. But, if you looked at this top level, there were many different projects, many different workspaces. And while it's, I suppose somewhat humorous to allow developers, anyone in here to access anything, that's probably not what we want. So HTTP Terraform does give us this concept of teams, right, and RBAC to get this done. So Kyle, I'm going to create a team here. Why don't you walk us through the idea of this?
And so a lot of what happens is that as organizations kind of evolve in their usage of Terraform, there's this requirement that multiple different teams are going to need multiple different types of access. And HCP Terraform supports a fine granular level of permissions access so that, in certain cases, if you have a security team who's managing your secrets or your credentials, you can now give them the appropriate access within HCP Terraform without actually giving them access to, deploy resources. Or on the other hand, if you have maybe more of a compliance team that needs to do policy or compliance checks and validation, those are also permissions that can be set. Or, hey, if you have developers who are directly accessing the HCP Terraform portal, you can also dictate whether or not they have access to state files because there might be sensitive information in there. There's all kinds of levels of permissions that kind of go along with this that you can make them as granular as you want to or as broad as you want to.
Nice. So I think if we're at the point where we're onboarding people and we've got the infrastructure as code going, we've got some of this RBAC in place, I think we've actually hit that adopting phase, right, Kyle? So if we hop back over here, I think it's good to move on.
Yeah. That's pretty much the transition point on moving from like when you start having multiple teams having access or requiring access into HCP Terraform. That's when you start hitting stage 2 and kind of the standardizing stage of how do we take some of those learned aspects from stage 1 and how do we standardize it across the organization so that kind of everybody can benefit from all of those learnings. So Cole, let's jump back into the demo to take a look at some of our options in stage 2.
Yeah, so if we hop back over to our original scores application here. This was pretty important for us because this was that end goal. But if we hop back over again into the associated workspace, or equipped with a bit more knowledge now of what was actually happening in here, which is pretty neat. But let me actually go back up to the overview because I mentioned, and Kyle has already mentioned and talked about it as well, the importance of a concept of a module in this theme of standardization. And although we've seen modules written specifically in our code base, which is certainly an option, what happens when we want to make a module available beyond the code base, or if we want to do even more with it, like which some of the stuff we're going to see here. Well, that's where the registry and the concept of modules within the registry come into play. And the Kubernetes app that we deployed into the game environment was actually using one such of those concepts, one of these modules here. So Kyle, tell us about this module and the concept of modules in our registry here.
So what we saw before, the concept of a module within our Git repository was kind of, that initial phase of how do we, build in certain best practices and, the way that we would like to see resources provisioned within an environment. And from that point, we need to get to the point where how do the consumers of those modules actually discover and access those modules? And that's where this comes into play as the private registry that's literally built into the HCP Terraform offering. And so what we have here is, as Cole discussed, this is that Kubernetes app that he deployed. This is where it's made available to people who can, filter and sort and discover this. However, that also gives them a level of documentation and information so that they can go back through and say, here's the requirements to actually use this module in our environment. And it also tells them additional information about, say, the resources that it's going to create.
Yeah, and we've already seen modules used like so, and this is certainly an option. The ability to specify the exact source, pointing to your private registry, which is the pattern we saw for using the runtime modules. Of course, we also see some neat stuff here around the concept of versioning, let's see, what else do we need to? I think we're going to get into the provisioning next. Or yes, that's a bit later, I believe, Kyle. But anything left on this screen before we go up to that top level view of the registry?
Nope, that's a good summary.
All right, so this is one such module. Again, this is just something repeatable, reusable. But let's take a look at all the modules available in our private registry to our team here. So these are going to be available, and we have a number of different applications through here associated with a number of different providers and whether or not they're public or private. So Kyle, what on this screen should we focus on?
Yeah, so the key point here is that, as Cole pointed out, there's both private modules that have been added here that me as a person within an organization have created and shared, but then there's also those public modules that are available out on our public registry. And this is a really great way to kind of bring them into the private registry and say these are approved. Now, the other important call out here is also if we take a look at the different services that are provided through here. This is just an example. There's literally like 15,000 modules that are out there in the public registry, and I'm sure there's so many more that are available privately. Also, this allows the module maintainers or authors to release modules at kind of their best practice or the way that they want to operate. So if we can also notice there are Git tag based modules as well as branch based modules. So regardless of how you are developing your infrastructure as code within your environment, the private registry can also support that.
So let's take a look at one more thing in here before we move on from modules. This is a different module that creates a function on Google and ties it up to GitHub. Specifically, it has some tests associated with it. If we go into testing, we will see a number of different test suites have been run in the past to assure that this module is solid. And Kyle, why is this important?
Yeah, so built-in unit testing, this brings it directly into the workflow of publishing a module within the private registry so that you can have those unit tests defined, and then it also goes through the process as it's being created and being made discoverable to our end users of these modules to give them kind of a comfort level that not only is this module supported by the module authors and the platform team, if you will, but they also pass all the tests, and so it will operate as intended.
All right, so modules being about the idea of consistency of the infrastructure being deployed, the code being deployed, but we have the runtimes themselves, and those runtimes, whether it be Nomad or Kubernetes, are sitting atop virtual machines. They have machine images. They're deploying containers that have container images. We need to keep consistency as well, consistency there as well. So why don't we head back over to HCP? Go back up to our dashboard and talk about how we keep those machine container images consistent in context of Packer, Kyle. So I'm going to open up the screen here and you can give us sort of an overview of what we're doing with Nomad.
Well, this would be Packer. But so what we're doing here is we're taking all of those images that we've created and defined and built using Packer, and we're creating a very registry-like experience so that those container images or virtual machine images have been built. They're registered into this Packer registry that's known as HCP Packer. So again, easy to discover and done in a very consistent way. As a former virtual machine image administrator, this is so much nicer than having to use the spreadsheets.
So let's dive in and see a little bit more information about the images associated with our Nomad client. So these are going to be the pieces inside of Nomad that are actually running our workloads. So we have some information around the bucket itself, but probably of more interest are the different versions of the images available to us, right, Kyle?
Yeah, so what we see here is, of course, when you're building images within your environment, you're not just going to build it once and then move on. You're going to have subsequent updates because there's patching and other installations that need to occur to certain specific images. And so what the HCP Packer registry is going to do is maintain a history of those different versions. Now, the important thing that we're looking at here is not only can we see, the latest versions that are available as part of that, but we can also see those older images because we have the ability to revoke those. And revoking might occur because it's simply aged out. There might be vulnerabilities. There could be so many other reasons, but this is a really great way to say, hey, nobody in our environment can actually make use of this particular image version.
And if we hop into V5 here, we can see that this isn't just referencing one image necessarily. It does represent the concept of one image, but it actually represents a different Amazon machine image across different regions without us having to do much more in terms of cherry picking those specific IDs. Yeah. Well, for time here, why don't we actually go and go look at how this is used in the code real quick, just to see how this helps our developers out. If we hop over into and see this actually being used in the runtime, If we go to our infrastructure, into our Nomad runtime, and into, say, these specific clients, we can see that, first up, we have a data source that's reaching out to HCP Packer and asking for the latest version of this Nomad client. And then we can see in the node pool here that we're actually down here with our launch template using this image ID, again, without actually referencing the specific AMI machine image ID itself. So Kyle, what are your thoughts on that?
Yeah, and this is just a really great way to kind of keep the workflow going without having to follow, a more intricate process. Historically, many teams would have to say, you'd have your image builder team that would be maintaining those images, and then they would have to relay information about what the latest and greatest version is. And this simplifies all of that so that actually on the infrastructure side, you don't have to think about it. You can use image channels to just dynamically reference whichever the intended image version is without having to change the code every single time an image has been updated.
All right, so let's look at one more thing here before we move on. If we head back over into our workspace, let's take a look at one of those Nomad ones, specifically in the reports here. And it's something we've seen quite a few times at this point. It's in one of these runs here, and it is these there's the Sentinel policies, which we'll get to in a second, but to just stick with the whole Nomad thing, we have this post plan, this run task for HCP Packer that is talking specifically about those artifacts, Kyle.
And so what we see here is kind of this concept of being able to use a feature that's known as run tasks. And run tasks is an integration directly into that Terraform workflow. So in this case, we're taking the output from a plan process and feeding it out to a third-party system for either validation or some sort of checking. And then that will feed it back directly into our Terraform run so that we can make actionable decisions based on that. So in this particular case, we're looking at an integration with HCP Packer that is telling us whether or not our image is still approved and has not been revoked. And so this is just a really great way that Terraform can automatically say, yep, we're still good, move on with the workflow. And this is available also for around the apply actions as well. This just makes the most sense to interject in between the plan and apply.
Nice. And we should probably just go ahead and move on to Sentinel as well. Plus, it's something that we've seen quite a few times here as that extra set of guardrails to help for consistency in context of standardization, right?
Yeah, so what we're looking at here is what we call Sentinel, which is a policy as code framework. And what that allows us to do is then still continue to take kind of that output from our plan operation and define guardrails so that in certain cases, much like the policy that we're viewing right now, we don't want anybody in our environment to deploy infrastructure on a Friday. Read-only Fridays are a thing. Nobody likes working late on a Friday or during the weekend. So we're just going to build that directly into our policy. But it's a very verbose framework that can assess a lot of different things and also can support OPA. So there's a lot of abilities and capabilities that come along with policy as code, and again, integrated directly into the Terraform workflow so that it's a streamlined process.
Yeah, and speaking of streamlined, I think we've hit that level of standardization. We have a lot of different workflows here to where when we want to add net new infrastructure, things are set in place that we're doing so in a way that's consistent, right? That's not going to lead to other things. So I think it's a good point to head back up to the slides.
Yep, so at that point in time, we've now built out those guardrails. We've standardized the way that we're deploying resources within our infrastructure. And so at this point, it's time to move on to stage 3, which is generally known as our scaling phase, because that's when it comes to the real value add of enabling self-service and letting those end users being able to self-request all their infrastructure and have it deployed. However, we also want to make sure that we're not losing sight or visibility into those resources that are deployed within our infrastructure because, of course, we're still going to be held accountable for maintaining compliance policies around those and also making sure that we're making the most efficient use of those. So let's jump back into the demo and take a look at some of our features in stage 3.
All right, so I'm going to hop back over and head back over to our registry. Again, we've said modules are important, and we were not. We're serious about that. In fact, we're going to go take a look again at that HashiStack Kubernetes app. Now, what's interesting about this is just to sort of set out a teaser here when it comes to developing an internal developer platform. If Kyle were to task me with that, I'd be like, that's going to take a lot of work, Kyle. It's a lot to get done here. But we already kind of have some of this here available to us with this concept of a no-code provisioning, so no-code modules. And we can see this Kubernetes app, this particular module is already ready to go. We've already seen two different ways to use this module, one through that in-game IDP that we'll get to here in a second, and another through writing the actual module. But there's an in-between here for the actual platform engineer if they want to deploy this into its own workspace. And so talk to us about no-code provisioning, Kyle.
Yeah, so no-code modules are literally as it sounds. It's not that we're taking away the code from the module, but it's taking away the code that's required in order to deploy the module. So if Cole clicks on the provision workspace button, we can see kind of that initial step to filling in those inputs that were defined on the last one. Take note, there's capabilities that are built in to make sure that we're doing some validation and checking, such as what we saw earlier with scores versus score, as well as these drop-down options that are built into the way that the module has been defined. Now, for the sake of time, we're not going to actually deploy this, but this is kind of the walkthrough on how this would operate for folks that have access to the HCP Terraform service.
So let me go ahead and cancel this to just back out. But this is something that you are going to both set up, just out of necessity when you start using a centralized registry of modules, and probably for yourself as a platform engineer when you need to deploy stuff. However, since you've done the work already, this is actually that underlying scaffolding you needed to create the internal developer platform flow for your developer. It begins with the module, with a no-code module. And once you have that set up, we actually get to head back to what we saw originally. And that's actually into Waypoint. So let me head back up to the HCP dashboard here, into Waypoint itself. And I clicked on it, and let's head into, well, first up, let's pause here so we can actually give Waypoint a proper intro and overview from Kyle.
Yep, so Waypoint is the self-service portal that Cole highlighted at the very beginning of the session, and this really just drives home the capability around self-service and being able to take each of those steps that we went through in each of the stages and building it into a very programmatic way for folks to self-service their resources that are required to do their jobs.
And so let's, if we have a no-code module, the way this works operationally, it's very simple. That no-code module maps to a template that you can make. So you can see here, you just get to give it a name, summary. You get to choose from those different modules that you've turned into no-code provisioning modules, as well as the project that those should deploy into. This template, then, you're also going to get the capabilities to decide, how much control and how many different tweaks the developer gets to make to it when they go to use it to create a new application. So let's actually go and create a new application from one of our templates. Inside of applications, we'll see a list of applications we've made in the past, the scores being the most recent one. But let's make a new one this time. And instead of doing it in our Kubernetes environment, let's make one in the Nomad reports environment. So I'm going to select that template for our application. I'm going to give it a new name. We'll call this user comments, since hopefully you'll leave us some good comments. I'll put it in the standard node pool. And again, we could have more options, but we've constrained this to our developer, obviously here for demo purposes. When I click create application, we will once again see we've come full circle here. We see that screen again. Our developer's done. The application's being deployed out into Nomad. However, as the platform team, we do have the ability to drop into HCP Terraform and once again actually see everything that's going on, everything getting deployed, and it looks like it's actually finished here. So Kyle, what do you think of all of this?
I love when a plan comes together.
Ha! You'd say it was applied very well. And let's see in Nomad if this was launched correctly. So let me go ahead and refresh the screen here. And here we go. We'll see our user comment service has deployed. It is healthy within our Nomad cluster itself. And I think we've got one more thing to look at here, right? There's a lot of workspaces, Kyle. So what tools do we have at our disposal to get the information across all of this different stuff going on?
Yeah, so putting back on our platform engineering hat here, now that we can provide the organization and folks within the organization a way to self-service resources and infrastructure, how do we maintain those things? How do we have a level of understanding about what's going on within this organization? And that's kind of where our friend the Explorer comes into play on the left-hand side. This allows us to go through and filter based on different aspects of our estate that we have under management with Terraform, taking a look at what modules are in use, what versions of Terraform, so many more things. But in the case of what we're looking at here, and for the sake of time, let's take a look at the health of some of our resources by looking at the drifted workspaces.
All right, click that in. Looks like we've got one.
Yeah, so if we take a look at the way that Cole was showing us the main portal there, like how would we get to this point when we have so many different projects and we have so many different workspaces? This is just a really consolidated way to get to that point so that, because a resource that's drifted is very important.
Yeah, so let me click into this. Let's actually get some more information. We've seen this workspace before, and probably some of you have noticed the little yellow exclamation point here. Let's get some more information about this drift going on.
Yeah, so what we're looking at here is what's known as drift detection. Now, the concept of drift when it comes to Terraform is the difference between a resource as it's been defined and a resource as it exists in the environment. And so what this is doing is it's checking against the configuration, the code, and the service, and it's found that something has actually changed within the environment. In this case, a node group has drifted away from the way that it's been defined. And so it's giving us that alert so that we have an automated manner of kind of detecting that that a resource is out of sync.
Nice. Now, there is one more area here around continuous validation, and the drift is detecting stuff after the fact. Well, continuous validation is another such case. And, if we hop back up into this top level workspaces area and into the game DNS workspace where we actually have some continuous validation set up, we'll see that we have another health assessment here within checks. This one specifically is for checking the game DNS itself, which within the code actually looks like so. I open up our checks file. All it's doing is reaching out to the actual DNS of the game itself and making sure that it returns a 200 status code. So continuous validation, Kyle, what else do they need to know about that?
Yeah, so that's kind of that next level checking and validation, if you will. So what we saw with drift detection, that was against the resources as they've been defined. And this is taking that next additional step to take a look at the actual workloads that have been provisioned, in this case, our game. We want to make sure that the DNS is working appropriately and so that people can actually make connections to our game. And that's going to tell us that it's in a known good state. Now, we could also change this to be based on pings or based on other types of checks and validation. It just depends on what you want and what your end goal for your provisioned workload is.
All right, and I think by making use of all of these things, we've hit that third section, right? We've hit scale appropriately with all of those things in place.
Yeah, absolutely. So that was, if you want to go to the next slide there, that was a walkthrough on how we moved from stage one as kind of that initial kind of consumption of infrastructure as code and start kind of building that out amongst the team into the way that we start using infrastructure as code from a more programmatic standpoint and standardizing it across the way that the organization operates into scaling in stage 3 and just being able to self-service our infrastructure and resources and workloads without losing that level of visibility and kind of control into the way that they're operating within our environment. And so with that is our session. So I want to leave some next steps here. So what we have is the code repository that Cole went through. That is available through the QR code. It's out there. Feel free to check that out. That's a really great resource, both in terms of kind of the stuff that we showed, as well as kind of just being able to play around with code in your own environments. Speaking of playing around with code in your own environments, developer.hashicorp.com is the location for additional documentation, as well as a whole slew of tutorials so that you can you can go through and try it yourself. And of course, if you're trying it yourself, you probably want to create a free HCP account. It's out there at our HCP service that we walk through. And of course, if you want more higher level information about the product suites that we have, that is now available out on the IBM.com site that's dedicated to HashiCorp. Anything else on your side, Cole, or are we ready to hand it back to Peggy?
I think that's all. I think we're ready to hand it back.
All right, thank you so much. I love seeing those demos. It's really great to get in there, see the product firsthand. I really appreciate you going through that. I know it's a lot for everyone to absorb, but this is really important infrastructure. It's really the backbone of your enterprise. So if there are any questions now, please feel free to drop them in the chat and we can ask them. But if not, if you want to take some time to think about it, you can always come back to office hours and we'll try to address those questions at 2:30 to 3 today if you think of anything after we wrap up here. But make sure that you do take the session survey. It'll be on your bottom left as the session ends. So we want to make sure we continue to improve TechCon. I want to thank Cole and Kyle for coming. This is really a great overview. So up next, we'll have a little focus on HashiCorp, the security lifecycle management piece. So we'll have more of our friends from HashiCorp joining us then. That'll be at 12:20 right now. You can take a break or you can join our sessions with Adam Chire. He's the co-founder of Siri. So lots of great insights on AI and how that's impacting innovation going forward. We appreciate you coming. Let's continue the conversation. So I see something in the chat. Let me go over here. Okay, there's a question. Can we configure data power with HashiCorp? So data power is our IBM product.
So getting into the, I'll let Cole Google to make sure that we either confirm that we do or do not have a provider. But the end result here is that if there's an API service that's available, that's going to be something that Terraform can talk to. So an example of all those providers, that means that there's an API service that it can reach out to. I know as part of, certainly the acquisition, there's going to be a lot of integrations that start building out a lot of those providers for a lot of the services that IBM offers. So if it's not something that we already have today, I'm sure that it's going to be something that will be a very fast follow.
Which service was it again? Apologies.
It's IBM Data Power, part of our API management and gateways solutions.
I do not see it specifically on here, though I could be overlooking it, but there is the IBM, yeah, so, but as Kyle said, if there is an API, you have the in-between provider that serves that glue code between the two. So it is something that is absolutely possible.
Okay, thank you. Appreciate that fast response. And if you need any more clarification, just reach out. So that's, I think we'll wrap up now to give you a chance just to take a little break and then come back at 12:20 for the next session. And remember, these are recorded. So if you think later, oh, what did he do in that demo? You can always go back and rewatch this and you'll have access to this just through the attendee portal. And then we'll also have the slides that were presented on the at a glance agenda site so that you can go reference those as well. So we appreciate everyone their time coming, and we hope to see you at the next session.